Yeah, welcome back everyone. Track 2 here, Florian Rappel moderating. I'm very pleased to announce our next speaker who will talk about microfrontends for mobile, Mo Javad, who is working for the consultancy Theodore UK there as a CTO, and I think he will share with us some really brilliant insights. So welcome on stage, Mo Javad.
Thank you so much, Florian. Good to see you, and very excited to be here with you all today.
Glad to have you here on our conference as well. I hope I pronounced the name correctly. Is it Mo Javad or
Mo is perfect. It's actually a very long name, so it's Mohammed Javad Kazali, and everyone either says Mo Javad or Mo Kazali. It's not on you, it's on me for having such.
Oh, good. So I'm happy to learn.
And kudos to you for organizing this conference. You and the rest of the organizers. Very excited to be here.
Thanks. I think everyone here at SmartBuild is doing a great job. So thanks again for the team, for all the speakers here, and of course for you guys providing this awesome content. So can you give us a sneak preview of what you will talk about?
Sure. Micro Frontends have been around on the web for a very long time. And oftentimes people talk about Micro Frontends as this concept that maybe can apply to mobile, but they're really maybe referring to modularized mobile apps. And so today I want to kind of talk about what might come with a possible vision of a micro front end for mobile. We have a little cool demo to show you all, and hopefully show what that could look like in practice if we take some of the things that we've done in the JavaScript world, pair it with a language that can work on the native layer as well, and see what we can share from the web world into the mobile world.
Cool. Very excited to see that. Stage is all yours.
Thank you very much, Florian. So thank you again, everyone, for tuning in. Very excited to be here with you all at the Micro Frontends conference, talking about micro frontends for mobile. It's a topic that I've been very passionate about for the last year and a bit, I'd say. And I think that we're on the cusp of something very exciting. And so glad to be here where we've got so many different micro frontends experts. And hopefully this will inspire everyone to start looking at mobile and seeing if we can take some of these great concepts and port them over. So a little bit about me. My name is Mo, as Florian mentioned. I actually head the mobile team of BAM / Theodo. So Theodo is a large global consultancy with around 700 different digital consultants spread across the UK, France, the US, and Morocco. And my role is specifically to work closely with some of the leaders in the mobile space, whether that's in native development, React Native development, and some of the folks that work in the Flutter space to see what the next trends are and where the industry is headed. And part of that involves micro frontends, which we're here to talk about today. And our company also has a sister company called BAM, and BAM does a lot of mobile open sources and has been a key part of the React Native ecosystem for a long time, building libraries like React Native Image Resizer and also tools like Flashlight, where you can use it to inspect the performance of your mobile apps, similar to how you would with Lighthouse on the web. So let's take a step back and do a little story time. About a year and a half ago, we were working with a client who wanted to build a full-scale streaming service. Now, this streaming service was not simply just a video playback application. It started to become quite complicated. There was video streaming, there was a news channel, there was articles, there was podcasts, there was social interactions from all of the users, and also a lot of really quite complicated content display functionality that needed to be created. And so the requirements were that there was a large number of features across web, mobile, and TV in this specific case with full feature parity. They had multiple teams of developers, and they had a very short turnaround. Now, being in this React Native ecosystem and being in the mobile ecosystem, in recent years, there's been this concept that's emerged around universal applications. And the whole goal and idea is that you can write once and run anywhere and have a single code base, with whether that is to target iOS, Android, web, or desktop or TV, and so on and so forth. And specifically here, the key point is that when you're using a universal application, it's not that they're using web views for each of these different platforms, and that's not the condition here. Actually, what we have is that a universal app will natively target each platform using native code. So when you look at the iOS app, that's rendering iOS text and views Android likewise, and on the web, we use the DOM. So it's a really powerful paradigm to basically have native functioning applications across any platform, whether that's web or mobile. And so as we thought about this application that we were building and this project that we were looking at, part of the challenge was we talked about multiple teams that are building at once. And at such a large scale application, we had about 15 developers from our side. There was another sort of 15 from the client side. So we suddenly had to quickly adopt to having 30 teams as we were starting to build out 30 team members as we were starting to build out this application. And so we landed on a folder structure that looked something like this. So within this folder structure, we had a set of packages. We had some apps. And so each of these packages corresponded to a feature specifically within the app's functionality. So it would be things like the homepage, a listening functionality for the podcasts, a reading functionality for articles, some common UI elements, the watch functionality for all of the video streaming capabilities. And each of these packages could be individually tested within a sandbox app that we've got showing in this folder structure, along with a main app, which was basically the amalgamation of all of these different packages put together in a fully functioning actual streaming application that we wanted to have. And so if you looked into each section of these packages, they had business logic that was written in JavaScript. They had common React Native components, a set of custom iOS components and code, because when you're dealing with a language like React Native or a framework like React Native, you actually have a JavaScript layer, but underneath it, you've also got native layer functionality. So within that package, we had a bit of everything. We had some iOS Swift code, we had some Android Java code or Kotlin code, and then we sometimes had some custom web code that was specifically only going to run on web, along with all of the React Native stuff. And so while we built this project, as you can see, just inside of a monorepo, and all of the teams were kind of building with the same target of bundling and combining everything inside of the main app, the next natural step that we started to consider was whether or not actually we can take this modularized app approach and start to look at micro frontends for mobile. So if we take a step back, we've gone through the story of micro frontends. If we were to just quickly go through it for those who are not familiar and maybe just tuning in for the mobile segment of this talk, the story of micro frontends ironically starts from the backend, where applications went from monoliths to microservices. So we had a basic application that handles auth, streaming, and payments. They're all within one umbrella. They're all one single application. And over time, you keep adding on more and more and more. And as the project keeps growing, you're inevitably stuck with a behemoth of an application. And the cognitive load for any single developer working on this project is going to be massive. So you're going to get slowed down more and more over time. And speaking from experience, as a dev on these monoliths, you're left feeling a little bit like our friend Harold here. And a lot of people were grappling with this in the early 2000s. And so the concept of microservices arose. What if we could take each feature of our backend and have it constitute a single contained service? And then each of these could be isolated and communicate via some sort of APIs and some event bus. And it looks scary. Well, the good thing is it's not scary for the application developers, but rather the platform teams now. So they're left feeling like Harold, the DevOps, and the platform engineers. So naturally, when you do something like this on the back end, well, the question arises, can we do it on the front end? And micro frontends, just quick primer, we've obviously been talking about it throughout the day. They're architectural style where independently delivered front-end applications are composed into a greater whole. And the classic example that people often talk about is the Amazon website. Each of these sections could be their own micro frontends. And the benefits of this is that we've broken down our team into feature verticals. There's less context for each team. Teams can be tech agnostic and use their own stacks and have independent release processes and cycles. This is going to be very important in a second, where we specifically dig into the mobile into the mobile space. But the tech agnosticism and the independent release cycles are going to be some of the biggest challenges that we have. On the disadvantages side, of course, nothing comes for free, and trade-offs oftentimes just move things from one side of a stack to another. There's added complexity from all of these different moving parts. Multiple different teams could have different technology stacks, which means there's more points of failures, and you now have this added orchestration and host layer that needs to manage all of these different micro frontends. So it's definitely not a silver bullet. It's not for many or for most applications. This is for when you're dealing with large scale super apps that may have dozens of engineers working for them. And if we look at the mobile side of things, well, if we wanted to constitute and think about how this would look like as an equivalent on the Amazon mobile app, we could have that there's a product description micro frontend. And this micro frontend specifically is managed and independently created by a single team and hopefully deployed by a single team. And we'll see that in a little bit. But also a shopping cart micro frontend, right? And these are totally independent features. Yes, they have some data that needs to be communicated across the board, but really that can be handled. That's not a problem. But each of these features could, in theory, be isolated, right? But it turns out mobile apps are quite different to web apps because apps are usually bundled and released via an app store. And so that really puts a question mark on independent release processes. Now, like we saw on the project that we were on, we were able to modularize our different features. So we could take the product details module and the shopping cart module and separate them up into separate parts of our code base. But the challenge that we had was we needed to come in and bundle these both into a single application. And then this app would need to be submitted to either the Apple App Store or the Google Play Store. And that Apple App Store reviewer would decide whether or not the application was approved or delayed. And so there's a real challenge here because even though we've separated the teams up into different modules and different sub-teams, ultimately, at the end of the day, when it comes to the release process and when it comes to the cycle of getting the features and the functionality out to the users, there's a big blocker within the App Store. And so this has left mobile developers basically aging beyond all repair. And so it's been a long-standing sort of joke within the mobile development community that, submitting an app to the App Store or to the Google Play Store can really age anyone quite significantly. And so in comes suddenly this JavaScript concept, right? We're talking about micro frontends. We've been talking about how you deploy for the web, and people think, this is quite interesting. Could we potentially learn from some of these concepts and make it easier to deploy for mobile? And that's where the React Native story comes into play. Now, React Native is obviously this very mature cross-platform mobile technology that can now also be targeting web at the same time. But when it comes to mobile development, React Native has been sort of leading the way for cross-platform for the last 10 years now. 9 to 10 years that it's been around. And really the core of it is that it comes down to how it works under the hood. And the interesting thing with React Native is that you've got two layers. There's the native layer and the JavaScript layer. Like we said at the beginning, and just a quick reminder, the way that React Native works is that it doesn't have web views that are pretending to be mobile apps. They're actual native functionality. The buttons that you have are native iOS buttons or native Android buttons, and all of the functionality, the camera, the maps that you may use, or any functionality that you may use is written in native and is native level functionality. So it feels as if the code was being written in Swift or with Kotlin. But on top of that native layer, there's a JavaScript layer. And that JavaScript layer basically has the business logic that will control the native layer. So the JavaScript layer can say something like, when I press this button, then I want you to navigate to the next page. But all of the buttons and the navigation are going to be handled by the native layer. So it kind of has a top-down flow of functionality. And so a byproduct of this is that we've got JavaScript and native. Well, could we simply take some new JavaScript and push it over to some sort of server or cloud and have our native app listen to changes for the JavaScript bundle and update the application? And this has been something that people really thought about in the early days of React Native and has become a gold standard within the React Native ecosystem, which is called over-the-air updates. And the whole concept with this is, and it's incredibly powerful, it means that you can update your JavaScript code, and as long as you don't need anything new on the native layer, you can effectively push that to a server and update the app without needing to go through an App Store update process. And this is great because you can have faster iterations, quicker bug fixes and releases, and ultimately it's great for iteration speed and having happier users. So it brings real value. And there's many different solutions to do this. There's many tools to do this, but one that is quite popular or was quite popular was Microsoft's Code Push. And so Code Push was a service, a managed service that Microsoft had in App Center where you could update your JavaScript bundle and it would host that on a server and automatically have the right client-side libraries to pull those updates into an app when the user launches an app from the background or when the app has been completely cold booted. Now, part of the challenge is that Code Push only supports an individual JavaScript bundle. And this is really at the core of how React Native works itself. React Native was never designed in a way where you could have multiple JavaScript bundles. It was always designed with the premise that there would be a single JavaScript bundle for the app that might contain different modules within it, but it's all going to be bundled once and deployed once to a single code push server or any other over-the-air update solution that you may be using. And so what that effectively means is we would need to find a way to take individual modules, code push them independently to the app with different JavaScript bundles. And so the user could have a compilation of these different bundles that are being independently queried from a server, all comprising together to create one whole complete application. And so that's something that I was trying to work on and create a POC of, and that's what this demo is going to show. So if we open up our demo, I've created a very basic React Native app, and I've called it My Cars because I couldn't think of anything more creative. But the gist of this application is that it has two separate JavaScript bundles. So this is required going into the very internals of React Native and looking at it. So we've got a home screen as one of the bundles, and the native layer handles the navigation. So these two tabs are part of the native layer. And then we've got another JavaScript bundle that handles the remote. So this is a sort of imagine this is a remote that tells you whether a vehicle is locked or unlocked. So if we go back to the home page right now, it's got a carousel, and this is all native functionality, but it's being orchestrated by the JavaScript. So it has a carousel that says, what are some of the cars that are in my garage, or I wish I had in my garage? And there's a Bentley Continental, there's this lovely Opel Corsa that is from a very, very, very long time ago. There's an Audi A4S line. And you can see things like this mileage is going up and down and some of the data is being changed. Again, all of this is native. Now, there's a few issues. One is, it says good morning, and it says it at any given time. Given that we're in the afternoon, we probably don't want it to say good morning all the time. And separately on the remote, it says vehicle open when the car is actually unlocked, which is a bit misleading because we actually wanted to show that the vehicle's unlocked rather than open, because open implies that the door is open, which is misleading. So let's look at our code base setup here. I've got a dashboard code base. This is an independent code base that's only implementing the dashboard screen. So it doesn't have anything with the second tab, which is specifically the remote. And here I register and say that's my specific app. And then on a separate code base, I've got the remote screen. And this remote screen only has the functionality for the remote. And so you can see we can go in and make those changes independently. This could be one team making the changes to the dashboard screen, and another being a team that's making changes to the remote screen. So I've changed the text in the dashboard. Now I'm going to go ahead and change the text in the remote screen. So we're going to change this from locked to from open to unlocked. And once that's done, I can start to create a bundle and code push specifically the remote portion of my app. So I'm creating a bundle and code pushing only the remote portion. And then I can do that independently from the dashboard screen as well. So these are independent builds, bundles, and deployments to some sort of server that's living on the cloud, where my app shell can start to query from and get the specific information related to it. Now, I want to dig a little bit into how this code also works on the native layer. What we've got a Swift view controller. I'm not going to go too much into the details of this because it's obviously a different language. But what it does is it uses code push to get a bundle URL. So it's saying, I have a resource that I'm looking for, and this resource is a JavaScript file that will tell the native view how to render things and how to behave. And it's getting that information from code push. Now, if we wanted to dig in, this has required some modification of the code push functionality. So we're going to look at some code push native layer code that's been modified to support these multiple bundles. And the way that this works is, and as we scroll through, it's got a set of Objective-C codes for this bundle URL functionality that gets the resource and the resource name. So this is the resource as it's being stored on the server. And we say there's one that's for the remote screen and one that's for the dashboard screen. And then it basically compares the state of the current JavaScript bundle that's being cached inside of the application with the JavaScript bundle that lives on the server. And it does a comparison of those two and starts to assemble the resource ID. And if the file is newer, it will store an update of that within the native application. So it has the most up-to-date version of the JavaScript code that we're looking for. And so it goes through some conditionals to check if the file name is equal and if the resources have been updated, and then goes through that process. And as soon as the code push functionality has run and our update has been pushed through, we can go through and basically we'll close down our app. And when we open up our app without going through any new builds, what we can see is that the app updates automatically. So you just saw a flash of the previous app and then the new bundles come in. So it's saying, how are you doing today? As opposed to good morning, which is quite cool. And then when we go into the other screen, we see now it shows vehicle unlocked. So this is a really cool example to just see how quickly things can be updated with this code push and not needing to do a completely new build. And I think this is incredibly powerful. It's a glimpse into what we could do if we could separate these bundles and do a different code push for each. Now, really the elephant in the room is that this is nothing new on the website. You know, Webpack comes with module federation, and I know that we've got Zach here as well today. And people have, in the React Native ecosystem, tried to take Webpack and use the module federation toolkit and the module federation library to basically be able to achieve micro frontends on mobile and on React Native. And one example of this is Repack, which is a rebuild or sort of a port of Webpack over to the React Native world. And it allows all of the Webpack ecosystem, including module federation. Now, there's one fundamental challenge here, which is that actually React Native doesn't use Webpack by default. It uses a custom bundler called Metro. And more of the community is now pushing to go towards Metro because it's the most optimal and the best bundler to use with React Native. It's the one that has the least troubles. So in the future, I can see a world where we potentially do a port of something like module federation, a mechanism by which we can support multiple bundles or chunks of multiple bundles inside of Metro natively. And when we look into this future, I think this future is very bright because we have now support for things like the federation runtime. It's something that Zach and his team have been working on quite extensively, which decouples Webpack from module federation, or rather module federation from Webpack. And using something like the federation runtime, where you can basically register those shared dependencies at your runtime and start to dynamically load remote modules at runtime, there's a real possibility to start introducing the potential for micro frontends within the mobile space and specifically within the React Native space. Now, there are still some challenges. Even if we solve the multiple bundle issue, there are still several challenges. Firstly, there's the issue of native code and dependencies. Now, if we wanted to add a new camera feature to our application, a camera feature would come with three main fragments. One would be some JavaScript code, one would be some Android code, and one would be some iOS code. And the challenge with this is that you can ship JavaScript code over the wire, but you wouldn't be able to ship any Android or iOS code over the wire because of the restrictions that Apple and Google place on remote code execution, specifically when it comes to native code. So there's a real challenge on having to update some native dependencies. If you need access to certain native layer APIs that you previously didn't, you would need to go through the actual App Store update process if you needed to change anything but the JavaScript layer. Now, the good news is you really don't need to change the native layers unless you are doing some major new feature releases. So for minor changes, tweaks, even changes that are large scale but don't necessarily touch the native layer, you can use this over-the-air update mechanism, which means that we have a good path towards having micro frontends run on mobile and separating and decoupling these teams. But ultimately, what this means is because you've got these sections of code that you can't ship over the wire, and it's only the JavaScript, your over-the-air update server that we saw might be able to successfully update one user's phone, but because of an incorrect version on the native layer, they may not be able to push that same update to another user, which would mean that they would be out of date and not containing the latest code. So there would be some inconsistencies. And so if we look at native code and dependencies, I just want to take another example just so you can kind of really think about this and visualize this. If there's a home feature, let's say we've got three features. There's a home feature. It doesn't have any native dependencies. So the last native update date is not applicable. We may have a camera feature. This will have some native dependencies, but the last update was 3 weeks ago. And similarly, there might be a share feature that has native dependencies that were last updated 9 months ago. So if we have 3 different devices, pardon me, if we have 3 different devices, one was last native updated today. So the last update from the App Store was installed today, and it has these 3 functionalities. Device B was last updated 3 weeks ago on the native layer, and device C was updated 9 months ago. And let's say we have a completely new, we want to see the state of these different devices in terms of how up to date they are with all of the different features, with all of the different sort of micro frontends that we've got. We would see that the device that had the native update will have access to all of the newest features, whereas device B will not have access to the camera feature in its latest form, and device C wouldn't have access to the camera and the share feature because they have new native code that was released after they last updated the native layer of their app. And so what this ends up meaning is that you've actually got this real fragmentation in terms of what version of each feature and each micro front-end your users are seeing. So there's a real challenge of trying to push users towards having the latest native versions on their phones so they could actually use the app with the latest functionalities that are being shipped through the JavaScript. And what that also means is you need to make sure that you've architected your application for all of the edge cases so that if there is certain portions of your application or certain features that will require new native code, that you account for that and that there's good fallbacks and sensible edge cases that will make sure that the user does not see any unexpected behavior, even if they don't have the latest and most up-to-date combination of micro frontends. The other issue, and this is going to being tech agnostic specifically, and giving each of these teams full independence, is that there is a need for matching dependencies and version pinning, right? We only have access to one layer of native layer dependencies. There's only going to be one set of native layer dependencies across the entire application. So what that means is you can't have version mismatches. So the example that we've got here is, the home feature, the home micro front end, and the camera micro front end, and the share micro front end, they cannot have different versions of libraries. So one can't be on React Native version 72, whilst the other is on React Native version 71. And one can't have a version of the notifications library that's on version 52 versus the other one being on version 50. So these mismatches just will not work because there's always going to be one central dependency version of the native functionality that you have. And so a potential approach is to abstract this upstream and make sure that each of the features are pinned to a specific version of the native dependencies. However, this removes from the independence and from the core principle of micro frontends, where each team needs to be able to be independent and shipping without having any of the sort of the tech baggage of any of the other teams and some of the old versions of dependencies and so on and so forth. The last challenge that I want to go over is repeated JavaScript bundles. So currently, because of there not being widespread adoption of micro frontends within React Native specifically, one of the challenges as well is that there will be repeated JavaScript code that's going to be shipped with each bundle. So you may have certain libraries that are used across both the home feature, the camera feature, and the share feature. And as long as they're being referred to in each of these features, these libraries will be included in each of the JavaScript bundles. And they'll be repeated codes. So it's not abstracted so that the libraries are in one part of the bundle or one chunk of the bundle, whereas the application code is in each different chunk. And this is, again, because there's a proprietary bundler, or there's rather a specific bundler for React Native called Metro, which doesn't support this because it's not been designed for this. So part of what we would need to do is we would need to make sure that there's good code splitting and there's a way to separate and chunk up the dependencies from the actual application code. What this actually means in practice today is that each of those JavaScript bundles are quite large. When we were looking at the My Car application demo that we had, the bundle size effectively doubled by adding a new micro frontend. Because there's no sort of separation and reuse of the existing JavaScript that's being bundled in one bundle. So this is just an important fact to keep in mind, and it's one that will need to be worked on over time to make sure that things are being done in the most optimal way possible. So we've talked a lot about where we can go in the future. I've shown you a POC, some very basic examples of how this could look like in the future and some of the challenges, but where does this actually leave us? And I want to point everyone to a very interesting talk that was done by someone from JP Morgan Chase, where they started to adopt a feature-driven design approach So they called it Micro Frontends Best Friend on the Chase UK app. And I thought this was a very interesting talk because it talked about how the Chase app took some of the principles of micro frontends and used it to speed up their teams and reduce the reliance of teams on one another, which is ultimately the goal that we're all trying to achieve, right? We can't be by the books, by the definition, having total micro frontends within the mobile space today. But there's a real possibility for us to split up our teams and have feature-driven modularized applications. And this is ultimately what we also did when we were looking at our app and when we were splitting up our app, and it worked incredibly well. And so that's what I want to leave you with today, with the concept of these modularized apps for today. And hopefully it sets up the right space for when micro frontends are introduced to the React Native and to the mobile community so that you can easily adopt and get the added benefits of having those independent release cycles. Thank you all very much for listening and tuning in. Those are 2 QR codes. One is for my Twitter and one is for my LinkedIn, in case you'd like to be in touch or chat more about micro frontends in the mobile space. And hopefully looking forward to the Q&A with Florian.
All right, thanks a lot. Before we go into the raffle, I think we have quite a lot of questions here, so let's cover them one by one. And
Sure.
we start with the question from David, which was still quite early in the talk. And I mean, he made afterwards a little statement that he knows is for mobile, and that was just a specific example. But he was interested to hear how you manage the search engine optimization, the microfrontend approach. Is it all by server-side rendering, or how did you handle that?
So the way that it works is on the mobile side, SEO is not going to be relevant. So it's all client-side JavaScript code, and that's how mobile apps work. They're more like an SPA than an SSR approach. So currently on the mobile side, those are SPAs. But what we actually did was we had this universal app, right? So we had web as well and TV as well. So on the website specifically, we took the same code from each of these modules and actually popped them into a server-side rendering engine that effectively made sure that the same code was being rendered with the right SEO considerations. And so we took that approach specifically on the web side of things.
All right, thanks. All right, next one we got from Aaron, who asked about the over-the-air update functionality. Is it allowed by the Apple App Store team? There is usually nothing quick about an app approval update process with
Exactly.
Apple. What are your experiences?
Well, this is actually without fail, every single time I've mentioned over-the-air updates, this question has come up by someone. So I'm glad that Aaron's asked the question. Yes, it is. And the reason is that Apple's specific guidelines say that you must not change the nature of the app without going through an App Store approval process. So there's tons of applications that are using React Native on the App Store, very, very popular applications that are using it, and it's all completely allowed. And it's definitely nothing against the rules. Obviously, with great power comes great responsibility. If you say that you have a social media app today and tomorrow you decide that you want to change that into a betting app, someone will report your app and it'll be taken down. But as long as you're responsible as the app developer, there's no reason that Apple would deny you from using it. No.
Okay. Aaron also is really interested in the OTA functionality. So do you have a GitHub repo with example code, how you're doing over the updates?
So I can definitely share that with you, Aaron, as well. But one thing that I would look for is you can obviously Google Expo. So there's 2 libraries that are there within the ecosystem. One is called Expo Updates, and one is called Microsoft's Code Push. Unfortunately, Microsoft's Code Push has just been announced that it's going to be deprecated because it wasn't something that was making them money. But Expo Updates is one that you can use, and that's by default. It's open source, and you can look at the code there. If you're looking for more specific application code, I'm happy for us to connect, and I can definitely share that with you if you're interested, Aaron. And if you have any way of sharing some more content with the audience as well, Florian, I'm happy to send some links, and we can
Awesome.
share those around and circulate them.
Yeah, we are also available in the Discord chat, so we can
Amazing.
keep the conversation going on even after the conference using the Discord. That was
Yeah.
our idea here.